Welcome to video 18 in a series of introductory videos for InventorCAM. This video's topic is threading. So the threading operation in the lathe or mill turn modules are the same as the turning. Really the only difference is the tool definition that drives the thread cycles. So let's take a look at how that works. First thing you want to do is define your threading tool. So you can either do that while you're in the operation or you can do it in the tool table. Using the functions we saw in video 2, I created this threading tool. So you can see that there are many parameters related to the tool. You can see that I've chosen the triangular shape of the insert. In terms of thread, I choose it from a table. So I chose UN thread. I'm going to go through here and I'm just going to choose the 2 1/4 by 4 1/2. Cutting direction, insert type. You've got all the different options in here, and then additionally you have the dimensions of the insert. From there, we can go right into the toolpath. So add turning, threading. So the workflow here is the same as what we saw in the turning video, where we just choose our geometry. I'm going to click on New Geometry. That blue sketch indicates that the stock has been updated, so the whole thing has been turned. We're just going to add the thread now. I'm just going to grab my geometry from there, and you'll notice that the design model doesn't actually have the physical thread. That's because it's not necessary for threading. All that's really needed is this one line. We're just telling it where along the part in the profile we want it to travel. The physical thread would just get in the way, because back when we saw the setup video on how to do lathe and mill turn parts, you saw that it spun it around the rotary axis. So if you had a physical thread, that wouldn't even be left behind in the profile anyway. It actually would get in the way and maybe make the file size too large as it's trying to parse every thread. So it's a good idea to have just this blank shape here. I'm going to go to Modify Geometry. And I'm going to turn off the auto extend at the start and the end, only because it wouldn't really do anything here because we have those chamfers already there. So it's already been extended to the stock. What I will do is add an extension. So I want to start 100th thou before the thread and end 100th thou after the thread. I'm just adding extensions there. From there, we go to Tool, Select, and let's just grab our tool. In this case, I defined just the insert because I didn't really want to look at the shank, but if you wanted to put the shank just to make sure it clears, you can add the shank dimensions there. I'll just make sure that it's mounted correctly. Levels, safety distance is the only thing that you see in the level section. That again is where it's going to retract to as it goes along the part before it engages any material. Under technology, we'll see that it has a similar layout to the turning toolpath in that it has outside thread, inside thread, face thread, and back thread. Again, thread type. If you click on user defined, you can actually plug in the information if you know what it is, or you can just go back to the table and rely on the standards. So let's go back to UN thread, 2 1/4, 4 1/2. And that auto-populates that section there. Under work type, I can do this as a single thread, or I can give it some step down. That way I can work my way through the threads, especially if the insert is smaller than the actual thread size. I can add multiple starts if I need to. I can add a thread finish and an external finish, whatever would make sense for what I'm trying to do here. Now, if we're going to do multiple step downs, I can tell it what pattern to follow. You can see from these images here exactly if it's one side, the other side, alternating sides, or right down the middle. And of course, under link, you have approach points and retraction points to the right safety corner. So let's just do a save and calculate on that. You can see the toolpath is going into the part. Obviously, it's a thread. That's what we're going to do. So let's take a look at this in the turning simulation. So you can see it's engaging the material and adding the thread. So simple enough. All you need to do is just define your thread from the tables for your insert and for the toolpath itself, and then the geometry is simply just that line. If you're doing any kind of other thread that has a taper to it, again, it's driven by the geometry. So as long as this line is at that angle, let's say for an NPT, then it will be at that tapered thread angle. Any questions of this or anything else for InventorCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com, and stay tuned for the rest of the videos in this intro series. Thanks for watching.